Hello guys, welcome again sa ating video for today. And today, magsasolve pa tayo ng more examples on Maxima and Minima. Okay? Um, so, for this video, meron tayong 3 problems to solve. So, padaanan natin yung problems. So, number 1, ito, a strip of metal sheet 30 centimeters wide is to be made into a gutter by turning strips up vertically along two sides. So, yung gutter, daanan ng tubig. Tama? Then, hanapin daw natin yung depth ng gutter to obtain the greatest carrying capacity. Yung next problem natin is related to physics. A student throws a ball upward, di ba, magtapon ng bola upward, okay, from a height 48 feet initially at 32 feet per second. So that is physics. Okay? So we're going to apply maximum and minimum, tong concept ng maxima and minima. Okay, for that number 7. And then sa number 8, what is the largest possible volume of a right circular cylinder if it is inscribed in a sphere of radius 5? So, geometry naman to. Okay? Meron kang cylinder na shoot sa loob ng isang sphere na may radius na 5. Okay? So, different problems ang isosolve natin. So, let's start with this problem. Okay? And ganito gawin niyo guys. If you have watched the previous videos, para matest nyo if you have learned something na, wag nyo munang dire-diretso yung panoorin. You pause this first, okay, then try to solve the problem. Then pag natapos ka na mag-solve, sabayan mo tong problem, tong video natin. Okay? And then isolve mo, and then i-compare mo yung solution ko sa solution mo. And malay mo, mas maganda pa pala yung pinag-solve mo. O, di ba? Sabihin mo yun, mas okay yung solution ko kay sir. Ganon. Okay lang yun. As long as the yung answer nating dalawa ay parehas. Okay? So, let's start with this problem. A strip of metal sheet 30 centimeters wide is to be made into a gutter by turning strips up vertically along two sides. Find the depth of the gutter to obtain the greatest carrying capacity. So, parang ganito yan class ko, para ma-visualize din nyo. Tingin kayo dyan sa video ko. Meron kang 30 centimeter sheet, itong wide niya. Okay? And then, gawa ka ng gutter by folding yung two sides. Siyempre, yung parang ganyan dati niya, di ba? Oh. Yung daanan ng tubig niya, gutter, doon sa bubong ninyo, doon sa pagfloan ng tubig, yun yung gutter na tinatawag, di ba? Pagfloan ng tubig. So, magiging ganyan na siya. Okay? Ang tinatanong is, what is the depth of this gutter daw? This one, kung itong buong to, kung haba nito ay 13 centimeters, paano yung pagkakahati nito? Okay, so ano yung magiging ang taas nito? Okay, itong both side dapat parehas yan to obtain the greatest carrying capacity of the gutter. Okay? So, hope na visualize nyo. Nakita nyo itong hawak ko? Yes? O, magiging ganyan. From original metal sheet na like that, magiging ganyan. Now, the question is, find the depth. Okay? Ano yung height nito mamaya? Yes? Okay. So, first things first, we have to illustrate. Okay? We have to illustrate. And then, pag drawing natin siya class, ganyan yung magiging itsura niya. So, originally, we have a metal sheet which is 30 centimeters. Okay? Yung dito sa baba, that is 30 centimeters. This one class, that is 30 centimeters. Okay? So, ito yung sa baba niya, that is 30 centimeters. And then, gagawin natin siyang gutter by flipping these two tong side, pataas, pataas. If flip natin to, so magiging ganito yung itsura niya. Okay? So, we have your X now, your Y, and then the X. Oh. And the total of this class, itong tatlong to ay 30 centimeters. Okay? Step 2, gawa tayo ng mga equations natin. Okay? Kung makikita mo class, so we have a perimeter of 30 centimeters. Okay? So, 30 centimeters is, so perimeter natin, that is equal to x plus y plus x, or that is 2x plus y. Okay? And then for kung class, syempre ang isa pang equation auxiliary equation na makukuha natin dito is by getting the area of this. Diba? Pag kinuha natin yung area niyan, class, that is equal to x times y. Okay? Kasi, bale, yung area nito, mamaya, class, ang kukunin natin to obtain the greatest carrying capacity. So, that means, class, yun yung ating i-maximize. Okay? Yung kanyang product. Yun yung ating i-maximize. So, that is x times y. Ngayon, ang problema natin is that dalawa yung variable natin dito wherein kailangan natin siyang gawing isang variable lang. So, balik tayo dun sa original problem. Di ba ang perimeter natin, class, that is 2x plus y, that is equal to 30. Tama ba? So, pwede kong palitan si y in terms of 30. So, para hindi ka na mag-simplify, si y na lang palitan natin, wag na si 2x kasi mag-over 2 tayo dyan mamaya. So, y is equal to 30 minus 2x. Okay? So, area now is equal to x times 30 minus 2x. So, area is equal to 30x minus 2x squared. Okay. So, isang equation na lang yan. Ay, isang variable na lang meron siya. Ano yung next dyan, class? Diba, we get the derivative and then we equate it to 0 para makuha natin yung critical numbers or yung value ni x. So, the derivative of a with respect to your x is equal to, derivative of 30x is 30 minus the derivative of 2x squared is 4x. Okay? And then after which, we equate it to 0. So, maging 30 minus 4x is equal to 0. So, 4x now is equal to 30 divided by 4. Divided by 4, cancel, x is equal to 30 divided by 4, that is 7.5 centimeters. Ano ba yung hinahanap? Diba, ang sinabi lang naman is, find the depth of the gutter. So, we're just solving for the value of x. Okay? So, the answer there, class, is 7.5 centimeters. Okay? Kuha? So, that's for problem number 6. Next, we have problem number 7. Ang sabi dito, a student throws a ball upward from a height of 48 feet initially. Okay, so 48 feet initially, sabi doon. And then at 32 feet per second. A, write the position function that models the height of the ball t seconds after it was thrown. So, ibig sabihin, class, nasaan na yung ball, okay, after yung seconds na tinapon niya. Okay, siyempre, pataas na siya. And then, B, what is the maximum height of the ball? Ano yung maximum height na na-reach ng ball nung tinapon niya pataas? Okay, so parang itsura niyan, class, is yung bata, okay, there's a boy. Ito yung cliff siguro. There's a boy, ang sabi doon, a student, okay, throws a ball upward from a height of 48 feet initially. So, from a height of 48 initially, so this is 48 feet na, class, andito yung student. Okay? Ngayon, nagtapon siya ng ball. Okay? There's a ball, tinapon niya upward. Okay? Siyempre, pag tinapon mo yung ball pataas, darating yung maximum point, class, sa taas. Hindi man forever na pataas siya, di ba? Okay? Darating yung point na marireach niya yung maximum height niya and then bababa na ulit siya. Okay? Marireach yung maximum point. So, ito na yung magiging maximum point ng ating ball. Okay? So, hanapin natin, class, yung function, position function ng ball. Okay? T seconds after it was thrown. And then, yung next question natin is, what is the maximum height of the ball? So, ano yung maximum height ng ball? Okay? So, ipa-plus na natin siya mamaya. So, itong height na nakuha dito, height, nung tinapon siya, height 1, and then itong height 2. So, this is the maximum height of the ball now. Okay? Maximum height of the ball. Okay. In your physics, syempre meron kayong discussion sa physics na. I'm not going to discuss it here na kung paano nakuha, pero i-recall na lang natin siya. One application of the derivative involves the height of a free falling body object, which can be modeled using the position function. So this is the formula class in physics sa position function. Okay? Height is equal to negative 16t squared, okay, plus the initial velocity times the time it was thrown. Okay, how many seconds? Okay, the time in seconds, and then ho is the initial height. So given naman lahat yon. Initial height is 48 feet, and then ano tong 32 feet per second? That is the initial velocity. Okay, so meron ka ng position function. Okay, so meron ka na ring drawing. So next is, ang gagawin na natin is gagawa tayo ng mga equations natin. Okay. So, saglit lang. So, isa-substitute natin ngayon, class, dun sa position function natin. Okay? Sa substitute natin, wherein you have your position function. Ano sinasabi this? Write the position function that models the height of the ball t seconds after it was thrown. So, hanapin natin yung height nung ball. Okay? Hanapin natin yung height nung ball after, so parang ano yung maximum height na marireach ng ball at this, after this second or after this time. Okay? Hanapin natin yung time na yon. Okay? So, meron tayong position function class wherein that is your h is equal to negative 16t squared plus VOT plus the original height. So, meron tayong given class na negative yung t squared natin that is unknown. Okay, yun yung unknown class. Okay? Plus the initial velocity given siya sa problem. Initial velocity is, that's 32 feet per second. So, times 32 feet per second times time, which is another unknown, plus the original height, which is 48 feet above the ground. Okay? So, 48. That is your height. Para makuha natin yung time, okay? Para ma-reach niya yung maximum height, we are going to differentiate this position function. Okay? Kunin natin yung derivative nitong position function natin and then i-equate natin siya sa 0. So, derivative of the height with respect to time is equal to negative 32t plus derivative ng 32t is 32 and then 48 is 0. And then we equate it to 0. Okay? So, becomes 0 equals negative 32t plus 32, or 32t is equal to 32 all over 32 all over 32, cancel, t now is equal to 1 second. That means, class, the ball will reach its maximum height after 1 second. So, nung tong bata, class, tinapon nyo yung bola sa taas, okay, marireach nyo yung maximum height after 1 second. Left push, ganun. After 1 second, andun na yung maximum height. Marireach nyo na yung maximum height, yung bola. Okay? So, that is at t is equal to 1 second. Okay? And then, to get the maximum height, that is for question number letter B, what is the maximum height of the ball? Siyempre, ano yung maximum height, class? Ito na. Ito yung position function natin. We just substitute now that 1 second into the original position function. Okay? So, yung letter B natin, that is h is equal to negative 16t squared plus VOT plus HO. Okay? The original height. So, height now is equal to negative 16 times 1 squared plus VO, that is 32 times 1 plus the original height, that is 48. And that will give us 64 feet. Okay? So, that is the maximum height of the ball from the ground. Okay? 64 feet. And ito class yung kanyang itsura. Okay, for a while. Ayan. So ito yung kanyang itsura. Yan. So, ito yung bola from the 48 feet above the ground. Okay, tinapon pataas. This is the maximum height na ball na na-reach niya. Then pagbaba, of course, ayan. Okay? 64 feet from the maximum height to the from the ground up to its maximum height na tinapon ng bata 48 feet above the ground. Okay? So, that's it. Next, last problem. Wait lang, solve natin siya sa the other sheet. Okay? So, what is, ito naman, geometry. So, what is the largest possible volume of a right circular cylinder if it is inscribed in a sphere of radius 5? So, meron tayong sphere daw, cylinder. Okay, or, tama, sphere and cylinder. Okay, there's a sphere class. Sphere is yung 3D ball. Okay, it's a ball. Assuming so, illustrate, we have a ball. Assuming that is a ball, ha? That's a sphere. Okay? Now, meron daw cylinder sa loob. Okay, there's a cylinder inside. Tsaka, gamit yun ng ibang color for the, cylinder. Okay. Alam niyo ang cylinder? Of course, you should know it. Okay, that's a cylinder. What is the largest volume of this? Ano daw yung largest volume of this cylinder, okay, para, if it is inscribed in sphere, para ibig sabihin, ang i-maximize natin yung volume ng cylinder. Okay? Ano yung largest volume ng cylinder na to para na mabubuo pag sinut siya sa sphere na ang radius ay 5, gawin natin siyang centimeters na lang. Ay, ang liit-liit naman. 5, sige, centimeters. 5 feet na lang. 5 feet, ang laki naman nun. Anong gusto niyo? 5 centimeters? Sige, 5 centimeters. Anong ginamit ko sa problem ko dito? Radius of 5 centimeters na lang para maganda. Okay. What is the largest volume of a right cylinder? 5 centimeters. Okay? So, pag mayroon daw sphere class, may sphere na ang radius niya is 5 centimeters. So, ibig sabihin from this point, okay, up to sa gitna, okay, that is 5 centimeters. Okay, that's the radius. So, from that point up to sa gitna, that is 5 centimeters. Ano daw yung largest area ng cylinder na pwedeng i-shoot dyan? Okay, what is the largest area of a cylinder na pwedeng i-shoot sa loob ng sphere? Ma-i-shoot, ma-i-fit sa loob ng sphere na may radius na 5 centimeters. Okay? So, ayan, we have illustrated it already. So, ang kukunan natin class is the possible volume. So, ang i-maximize natin is yung volume ng right cylinder. So, determine what is to be maximized. So, yung cylinder natin. And that is volume. And ano ang volume ng cylinder? Volume ng cylinder is, diba, we have the, pag mga ganyan, diba, ganyan ang cylinder class, diba ganyan. Diba, pag kinuha ang volume is area of the base, and then you have your height. Diba? Diba, that is area of the base times height. Tama ba? And the area of the base of a circle is pi r squared. Tama ba? Okay? Kasi circle yan, di ba? Circle yung nasa baba niya. So, volume is equal to pi r squared times yung height ng ating cylinder. So pag punta tayo dito, balik tayo sa cylinder class. Okay? So this is the total height of the cylinder. And kung radius sa gitna, this is height all over 2 and this is height all over 2. Okay? Okay. Ngayon, ang problema natin is dalawa ang variable natin. We have R and H. Di ba ang sabi natin is that dapat iisa lang yung variable. So, kuha tayo ng data doon sa problem natin para magamit natin doon sa ating problem. Okay? Para maging isang, ano lang siya, maging isang variable lang siya. Ito, kung makikita nyo dito, class, ilabas ko to. Okay? So, di ba, we have a radius of 5. So, this is the, sa taas class, di ba? And then this one. Okay? So, dito sa taas class, sa cylinder naman, that is the radius of the cylinder. Siyempre, circle. Di ba? Meron kang radius ng cylinder. So, that is R. Ito yung height niya. Okay, ito yung radius ng sphere which is 5. So, pag ika-cut ko ito, if I'm going to cut that one, okay, parang meron kang ganyan. Makukuha ang ganyan. So, this is 5. This is H all over 2. And this is R, the radius of the base or top ng cylinder, which is denoted as R. Okay? So, kung makikita mo, class, pwede nating i-apply ang Pythagorean theorem. Wherein, that is H over 2 squared plus R squared is equal to 5 squared. Or, if we're going to simplify it, okay, meron na tayong H dito. H squared all over 4 plus R squared equals 5 squared. Or that is equal to 25. O, gawin ko na siyang 25. Draw. That is equal to 25. Now, kung makikita mo, class, wag mo na pahirapan yung sarili mo. I-represent na lang natin ito in terms of H. Kasi pag R squared, meron kang R squared dito, si R squared yung papalitan natin. So, pwede natin itong gawing R squared is equal to 25 minus H squared all over 4. Tama? Yes. So, maging V now is equal to pi times si R squared, palitan ko ng 25 minus H squared minus 4. So, 25 minus H squared all over 4 times H. Lahat na ba in terms of H? Yes. And then, what we're going to simplify pa natin. V, pi H, okay? 25 times pi, that's 25 pi times H, that is 25 pi H. Minus H squared all over 4 times pi H, so para magiging pi all over 4 H cubed. Or pi H cubed divided by 4. Tama ba? Okay. Yes. Okay. So, lahat na in terms of H. By the way, pi is a constant. Okay? A constant number which is 3.14159, so on and so forth. So, treat mo siya as a constant. Pi all over 4 here is a constant. Then, pagkatapos niyan, kunin mo na yung first derivative niya. Derivative of V with respect to your H. Ito is kukunin natin yung H para makuha natin mamaya yung area o yung volume ng ating sphere. Okay? H. So, 25 pi H. So, derivative niyan is 25 pi. Minus, ito naman, class, is baba copy the base minus 1. So, baba mo si 3, magiging times yung constant nating pi over 4. So, 3 pi all over 4 H minus 1 squared. And then, we equate it to 0. So, 0 is equal to 25 pi minus 3 pi all over 4 H squared. And then, we have now 3 pi over 4 H squared equals 25 pi. Pwede ko nang i-cancel si pi kasi common sa both. Okay? So, H squared now is, ano yung nakuha kong value dito? 4 times 20, cross multiplication, that is 100. So, H squared, cross multiplication, 4 times 25 is 100, divided by 3. Tama ba? So, square root, H is 10 all over the square root of 3. So, nakuha na natin yung height ng ating cylinder. Ang area, ang tinatanong, class, is find the largest possible volume. Ang volume is area of the base times height, wherein ang base natin is pi r squared. Ang problema, wala pa tayong r. Okay? Pero, meron na tayo kanina dito, di ba? Nakalagay dyan na ang r squared natin is equal to 25 minus h squared all over 4. Okay? So, ang r natin, so square root lang natin yan. So, ang r natin is ayun, meron naman. I-substitute na lang natin to dun sa ating volume. Okay? Substitute na lang natin siya sa ating volume. So, volume is equal to pi r squared in terms of h is 25 minus h squared all over 4. Okay? So, r squared is 25 minus h squared all over 4. Ito yun, diba? From that original volume, okay, substitute natin si r squared ng 25 minus h squared all over 4. Ito pala yun. Okay, times your height. Okay? And then meron na tayong height which is 10 all over square root of 3. So volume now of the cylinder is equal to pi times 25 minus h squared. So that is 10 squared all over the square root of 3 squared all over 4 times height, that is 10 all over square root of 3. So volume is pi times 25, that is 10 squared, that is 100, all over square root of 3 squared is 3, so times 4, that is 12. 3 times 4 is 12, tama? 12 times 10 all over square root of 3. If you are going to use your calculator, okay, that is over 4. Okay, if you are going to use your calculator, this will give us, okay, the maximum volume is 500 pi all over 3 square root of 3 cubic, cubic centimeters. Okay, cubic centimeters. Okay? So, ganun lang siya. Mahirap ang maxima minima. Ang kailangan nyo lang talaga is keep solving. Solve, solve, solve. Yes?